Cool. Can everyone hear me at the back? Good, awesome. So good morning. This is going to be an interesting one. It's actually the second time I'm giving this talk, and it's quite new to me as well. So the topic that we have for today is, what if your content could talk, essentially. I would like you to scan this quickly, so you can also give me feedback pretty easily directly on my app. So I'll be able to show off that you liked it or you did not like it at all. So that would be really nice. So I'm going to give you a couple of seconds to just do this, and then we'll continue from there. Great, let's go. All right. Cool, awesome. So let me ask you a quick question. What if any book you read, what if any website you go to, what if any article that you're reading at the moment, it could talk back to you? What would that look like? When I was a kid, and I'm originally from Pakistan, we had this really nice magazine for kids called Naunihal. So if anyone is from Pakistan, they might know about this. And that was really important to me as a kid, because every week I would just wait for that magazine, not only because it had a lot of fun puzzles to solve and a bunch of jokes, but also because it contained a lot of stories. And those stories were really important because of the messages that they gave, but also the narrative that we have as a culture. Stories are something that actually engage us. They are also something that shape us. They make us who we are. You might remember stories from your parents, your grandparents, your teachers as a kid, and how we behave as a nation as well depends on the stories that we have learned throughout the years. What do we do when we hear a story? What do we do when we are watching a movie? What do we do when we are reading a book? The first thing that comes to our mind is questions. We want to ask questions. Questions like, what happens next? Is there a twist to the story at all? Or important questions like, why did the rabbit not set an alarm when running against a tortoise? He could have easily woken up and won the race as well. Or why does the rabbit even need to have a race with the turtle to prove that he's fast? He's already fast. Questions are actually the heart of every story, and we as species have a lot of questions and have a lot of stories to tell. In every story, we want to know more. What if your website, content, book that you have created for someone else, or any article, could be the storyteller to the reader? And that's exactly what we are going to talk for the rest of this talk. So a bit about myself. My name is Ahsan. I'm originally from Karachi, Pakistan. I live in Sweden right now in Stockholm City, and I'm also a software architect at a company called Scania Group, and I'm a Google acknowledged expert in Angular for the past 7 to 8 years. I'm also an author of 2 worldwide published books named the Angular Cookbook, and I do a lot of open source contributions, a lot of YouTube tutorials, a lot of courses as well. And you can find me on these links, of course. I'm also a multi-award winning educator as well. This is from actually last week when I went to JS Poland, and I got this nice little award that you see here, the same logo here that you see. So same conference, same t-shirt, same award. Now let's talk about the talk itself. The content that we consume, and we have been consuming throughout our whole years, has changed over time. If we look at the 1800s, we had printed media. We had magazines, we had newsletters, we had books, for example. I mean, we have now as well, but that was the main source of content for us. In the early 90s, we had the rise of internet. So things became online, which started just for research papers, now is super dynamic. We have so many apps, so many content. In the early 2000s, we had social media. Who remembers Orkut? No? Am I that old? Come on. Okay, so someone knows, at least one person. So we had Orkut, we had MySpace, we had Scrapbook, a lot of those things before Facebook, Instagram became popular. Then in 2010s, we had visual storytelling. Vimeo, YouTube, they got popular, and we started consuming more videos than actual content or books. In 2015 to 2019, live streaming became really popular. We had the rise of Twitch, we had Facebook live streaming, we had YouTube live streaming, and whatnot. But not only that, from 2015, we also started consuming content in a different way. Not only we were watching videos, or even today, not only we watch videos, but we also get thrown these ads to our faces that we have to wait for a while to skip. So we consume content not with just videos, but also ads. And in 2020s, we got a really different sort of kind of material that we started consuming. AI bots became really popular. Every business wanted their own chatbot that could talk to their clients. And we started working with AI, and AI generated content became popular, and it's still popular today, and it's growing. In 2023 and 2024, RAG and advanced LLM techniques became popular. And the basic fact for that is computation has become much more accessible, but not only in terms of hardware, but also softwares. For example, all these models like OpenAI models, not OpenAI, but similar to OpenAI models, we have so many open source models that people are actually fine-tuning, they're working with those, they're creating so many use cases, and that has become more common to developers, but also to general audience as well. And I don't know what 2025 is going to have, but it seems exciting and promising. Let's have a quick walkthrough of what LLMs are and what is generative AI in general. So what is a large language model or an LLM? If you talk about ChatGPT, that's an LLM. For example, GPT-4o, GPT-4o mini, GPT 3.5. If you have worked with coding, you might have seen Claude or Claude. You might have also seen Google Gemini models as well. There are also open models like Gemma. What are those? An LLM is a bit different from a traditional machine learning model. When you work with traditional machine learning models, you try to give it an input and you expect a prediction. For example, when would it rain next in this city? That would take the whole data before already that it has been trained on, and it just provides you an output. With a large language model, you go sequence by sequence, and for every next prediction, you need to have the whole context of the question before. For example, if I try typing in my chat, in my phone, it's raining cats and it's already going to suggest me dogs. And this is so common now that we have it in our phones. If we use Gmail, it's there. If we use Google Docs, it's there. If we try to just type a message in our phone, we see this all the time. So what this basically does is that the large language model keeps a track of what you have asked before or what you have entered before. Let's call it query. So it has the whole context of your query, and then it suggests the next word or the next output. And the value of that distinguishes between 0 to 1. 0 means very bad prediction, so it's not going to be what you're looking for, and 1 means it's very close to what you want. So for example, if I'm saying it's raining cats and the most probable thing is dogs in this case, and you can see the value of that is 0.9, which is very close to 1. Similarly, if I'm trying to type my favorite food is a, then it's going to probably suggest me bagel and some other things as well, depending on the data it has been trained. If I choose bagel, then the next word it suggests is with. If I say with, then it also adds cream, so it suggests bagel and cream. Now you can see that for every next word, it has to have the whole context of all the words before as well. And that's what a large language model basically does. It keeps giving you the next prediction based on the outputs before and what it has been trained on before. Now, when we work with large language models, you are going to hear this term called tokens. How many of you know what tokens are? Okay, awesome, good, more people. So tokens are basically when you send a question to a large language model, it distributes that into different tokens. For example, if I send and ask, what are the best places to go in Venice, then it will distribute all of that into chunks, and those chunks will be called tokens. Just like when you go to a marketplace to buy milk, you need to pay some money. Similarly, when you go to an LLM to ask some questions, you need to go with some tokens, and it only allows a specific amount of tokens per LLM. There's no exact calculation of what a token is or how to calculate a token, because it depends from one large language model to the other. But in general, you can say that 4 characters in English is 1 token, about 75 words is 100 tokens, and if there's a paragraph, it's about 100 tokens as well. So let's take an example. This is AI Studio from Google, so aistudio.google.com. When you go there and when you ask a really simple question like, can you help me write an essay on why I need an RTX 4070? How many of you know what that is? Good. So I need that essay so I can give it to my father, get some money, get the RTX, you know. So if I'm using this, then AI Studio says out of 2 million tokens that AI Studio supports, I'm consuming right now 22. So the more I give it, the more tokens will be utilized. So just this query sentence that can you help me write an essay, it consumes 22 tokens out of 2 million. If I try to use an image with some text, it goes to 274. So it consumes more tokens when you give it an image. Now remember, everything that we try to give to an LLM is eventually going to be converted into text. So if you have an image, it can convert that into text. If you have an audio, it can extract out text as well. So ideally, whatever you give to the LLM as your query, your question, and the context, it will add those to the tokens. So going back to the text is 22 tokens. This is 274 tokens. Let's say I press the run button. I get a response back. If you see on the right side, the tokens have increased to 327 tokens, right? So I've asked it a question. It gave me the answer. I've not asked any more questions, but it's still the token increased. Why? So here you can see just my question, 274. My questions plus the response, 327. Why did that happen? Anyone? Yes? Exactly. So at this point, when I send more question, the LLM will require all the chat. How many of you have used ChatGPT? Okay, good. Oh, expected. So when you ask ChatGPT a question, it knows the whole history, what you have talked before to it. And that is how it does it. It not only sends your next question or the most recent question, it sends the whole history back to the LLM. So anything that you ask is going to be consumed in the tokens, and the responses from the LLM will also be counted into the tokens. So that's really important to know, so you don't run out of tokens. All right. Now, how many of you heard about this term named hallucination? Exactly, really important topic. So whenever we are choosing a particular LLM, we are like, it should not hallucinate. Hallucination means that the response that the LLM is giving is not accurate. It's making things up. It's not the truth, so to say. So there are 3 different techniques which are used when improving the quality of the response of an LLM. So we have prompt engineering, that's the first one. We have fine-tuning models, and then we have something called RAG. And in today's talk, we are going to talk about RAG. How many of you have used all 3 of this? Okay, good. How many of you have used at least 2? Okay, how many of you have used at least 1? Cool. So prompt engineering is something that we'll talk about as well, but let's have a holistic view of what are the differences between those. Prompt engineering means, in simpler terms, that I have to ask better questions. That's it. If I go to, let's say, any stranger on the street and I say, where can I get, or I want to buy something, the next question would be, what do you want to buy? If I ask the first question as, I want to buy milk, that's a better question. If I say, I want to buy milk from this grocery store, where can I find it? That's even a better question. So the question that you ask LLM is really important, and the quality of it really matters as well. These 3 techniques can be used in a variety of cases. Depending on what you want, you will choose one of these or multiple of these. When it comes to prompt engineering, it's very easy to use. For example, go to ChatGPT, ask a question, If it doesn't give you an accurate answer, just rephrase your question, ask a better question. It's really easy to implement. Anyone can do that. And it doesn't cost anything. You don't need to redeploy the whole ChatGPT environment. You don't need to call the contact and say, it's not giving me right answers. You just need to ask better questions. Super easy. When it comes to fine-tuning models, it's a bit more expensive. When a large language model is ready for you to ask questions, that means that it already has been trained on a huge data set already. So people have spent time, computation, resources, and now it's ready for you to ask questions. But if you want more accurate answers and you need to fine-tune, that means you are going to provide more data to the LLM. Then you're going to retrain it, and then it's going to be ready for you to ask more questions. Now imagine a world where you would want this to happen for news, right? That means every day the news is changing. Then you would have to fine-tune your model again and again and again. That's the whole reason why ChatGPT or other models have a cutoff date. For example, 2023, I think it's for ChatGPT, at least for 3.5. So that means that it's not really easy to fine-tune a particular LLM without the computation cost being there. And that's really, really important to understand. So it takes more resources, more time, more energy, and then also to decide when would you fine-tune it. In case of this news example, would you do it every night? Would you do it every 5 hours? Would you do it every 10 minutes? That also would increase the cost as well. But the benefit of that particular approach, when you fine-tune something, is you get really accurate answer. For example, if I have a pharmaceutical firm where I sell medicines, and I want a chatbot that can respond about those medicines that I create in my company, then it's really nice to have fine-tuned model because it would be trained on my data. But that also limits the response of the LLM, which means that if I ask my medicine chatbot what is a potato, might not answer. Or if I ask about something very generic, for example, good places to go in Pakistan, it might say my data doesn't really tell me that particular information. So fine-tuning means you really narrow the scope of the large language model and you get better answers. As I said, there's a cost to that you need computation, time, resources, and also managing this whole infrastructure. But then we have the third technique, which is called RAG. How many of you used RAG before? 1, 2, 3, 4 including me, good. So RAG means that, let me give you an example. For example, I am really bad at Google Maps or maps in general. I don't know which country lies where at all. So I rely on Google Maps, or I have my wife. She is like a brainiac when it comes to it. So if I have a question for myself, that if I want to find out where does Italy lie or compared to Sweden, then I would have to retrain myself. I would have to look at the Google Maps sometimes and then come up with the answer. But if I ask my wife, I don't have to do anything at all. It's super easy, convenient. Just go ask, and if something changes, let's say Italy moves from left to right, then I can just ask her and then she would tell me. So RAG works in a way that you don't really retrain your model again. You just have another data set which is served as a context. Let's give an example. Let's say you have a company which is an enterprise company that has their onboarding document. So whenever there's a new employee that comes in, it has to go through the whole document to realize how many holidays the employee has, what are the working schedules, what are the winter vacations, summer vacations, what are the guidelines for security, how do they get their laptop, when should they change their passwords. There's so many things that go on there. If that onboarding document is something that changes frequently, then you don't want to use fine-tuning, because then you would have to retrain the whole data. But if you use RAG, then you can just point to the website or the documents, and all you need to do is when you update the document, you just regenerate that data set or the embeddings. Your model does not need to retrain. Your applications don't need to redeploy. You don't need to change anything at all. You just change the data and then you get better answers. And that's really, really convenient, because it not only gives you lesser expense, but also it gives you real-time data. If anything changes, you will always get up-to-date data. So this is a bit of the evaluation criteria. I'm going to go through this quickly. So let's say if your project requires that it's a very common knowledge, for example, what are the good places to go in Venice? That's something that the large language models already have been trained on. So there's, I mean, all of that information is on the internet, and ChatGPT, etc., have been trained on the data from the internet. So they know that. So when that's the case, you can just use prompt engineering, ask better questions. You don't need to fine tune or use RAG. If your system, your application requires domain specific knowledge, for example, medicines, you can't really go wrong with that. Or if you have a chatbot that talks about law in Italy, then you can't really give weird answers. You need to be very specific from the book. That's when you can use fine tuning. Or when you need to have up-to-date data, for example, in terms of law, you might want to retrain the law whenever, or the data whenever the law changes. Then you can just use RAG in that case, because you will have up-to-date information all the time. You don't need to retrain your model. When it comes to budget, prompt engineering is the least expensive. All I need to do is ask better questions. No redeployment, no text generation, nothing at all. When it comes to RAG, it depends on your solution of how you're implementing RAG or how you generate the data context. We'll look into that in a bit as well. But when it comes to fine tuning, that's the most expensive one. Then we also talk about time to deployment. If you have a bug, if you have to release a new feature, how quickly can you go to production? How quickly can you deploy your solution? With prompt engineering, not a problem at all. Just update your prompt, redeploy, no problem. When it comes to fine tuning, you need to retrain your own model. So it takes a lot of time. It could be giving wrong answers in the meantime as well. When it comes to RAG, again, it depends on how complex your RAG solution is, but it's still going to be easier than the fine tuning when it comes to computation and resources. When it comes to complexity of implementation, fine tuning really easy to do, RAG medium complexity, and fine tuning a bit more, because you need time, resources, and an infrastructure or a method on when to fine tune and how to fine tune, how to test it. When it comes to transparency and interpretability, and by that, this is going to be interesting, and by that, this is a really important topic, transparency and interpretability. That means, how do you know the large language model is telling the truth? How can I know when someone is telling the truth? If my wife says croissant is the best breakfast in the world, how do I know? I need to go to the source to that. How do you know? Where did you see that? Is there a research on that? That's what transparency and interpretability means. With fine tuning, you can't really do that, because the large language model, how it gives answers, people say it's a gray area. So you don't really know where the answer is coming from. Same goes with fine tuning. So prompt engineering means you're using the existing model. Fine tuning means you're using the model, but it's fine tuned. But when you go with RAG, you actually know exactly where the data is coming from or where it got the answers from. That's the best part of RAG, that you know exactly where this is giving the answer from. And we are going to look at that in a minute as well. So having said that, let's talk about when should you use RAG compared to the other techniques. So when it comes to fine tuning, you can use RAG when your knowledge is out of date. For example, fine tuning prompt engineering means that you are asking questions from ChatGPT or Google Gemini, but if their knowledge is out to date, then you won't be getting the results that you want. Similarly, if the large language model cannot get your private information, for example, my medicine company or this organization's onboarding document, then you might want to use RAG, because you need to provide those. And to avoid hallucinations altogether. So if you're asking just a simple question, it might not really give you the answer if you're not using RAG or fine tuning. And especially transparency and interpretability. This is a topic that's really, really important for it's a lot of debates going on around how do we know the response is accurate, how can we get to the source of it, and RAG basically shines in there. When it comes to fine tuning versus RAG, fine tuning is really expensive, as I mentioned. You need to retrain your model all over again, you need to redeploy it, test it. When it comes to time and resources, fine tuning takes a lot of time and resources compared to RAG. When it comes to complexity, it's much more complex than RAG itself. So how does RAG work? Now this is where we actually go into the part which you're probably here for. How do I implement RAG? So there are two steps for this. The first thing is documents. You take your whole documents. Let's go to the example of the company onboarding. So if you have your onboarding documents, your holiday documents, your security policy documents, all those documents go through an embedding model which creates a vector database. This embedding model is not the large language model, just to be clear. The large language module is basically used to give answers back to the user, but this embedding model takes the documents and generates a vector database out of it. The second step is when the user asks a question, it goes to the vector database via the same embedding model. So the embedding model now